right, so I will talk about the quick quiz, probably for maybe half an hour, okay, and then a little bit about the final examination, okay. We have a couple of MC questions, actually 20 MC questions. So let's go one by one, okay. Actually, some of the questions are very straightforward, okay. So let's look at the question here. This is the first question. Which of the following documents gives the electrical load assessment procedure? Okay, so I guess you already done that kind of seen in your mini design project. So I guess most of you already got the right answer. Okay, so that's A, CLP, COP 215. Okay, and then so this is a straightforward question. The second one, according to the COP for the wiring regulation, what is the maximum floor area served by the ring circuit using 13 amp socket outlets, protected by 32 amp circuit MCB? Again, if you know the COP, okay, there are certain requirements regarding the final circuits. Again, you already done such kind of thing in your mini design project, so suppose you know this well, okay. So here the answer is 100 meters square. Okay, again, this is a straightforward question. Number three, according to the requirements for commercial buildings by fire service department, the emergency lighting should be activated within, here is 5 seconds, and all the batteries for the emergency lighting circuits, okay, let's say the answer should be A, okay, 5 seconds and 2 hours. Okay. So basically this is the requirements. Again, if you want to do the design for the emergency lighting, okay, you have to know this basic requirement. Okay. Okay. And question number 4: which of the following could be possibly location of the transformer room according to the COP, COP 101? Again, so if you've done the design project, okay, you're supposed to know that one, okay. The area on the up basement of 2 basement floors direct below the transformer room. Okay, so basically, you know, if you look at the other parts, okay, other choices, okay, they are not considered as good choices. Okay, for example, for the area with wet environment, so this is certainly should be avoided. Okay, so we don't want to see any water leakage, okay, in the transformer. Okay, so that should be avoided. Okay, so the answer is A. Okay. Okay, number 5. The electricity consumers lives in the new territory in Hong Kong. The electricity cost will be measured by which of the following parameters? So we have a kilowatts hour, kVA, and a few clauses. And for the residential customers, okay, normally the power company will charge using the kilowatts hour and a few clauses, okay. And the kVA, the maximum demand, only consider for the commercial users. Okay, so for the residential users, only consider the energy, okay, cost. That means the kilowatt hour and the fuel cost. So the answer is A. Okay. Okay. Number Number 6, okay. Which of the following is true about the resistive and the capacitive circuit? Well, the power factor depends on the total resistance and the total reactance. Well, basically that's the definition of the power factor, okay. Well, B is certainly is not right, okay, because this is just for capacitive load only, and it has a lagging power factor. Lagging power factor basically is for inductive load, okay, and the reactive power is used by power output, okay, so this is not correct. So the answer should be A, okay. So power factor is determined by the resistance and reactance, okay. Number 7, why can power factor correction reduce the circuit power loss? So here the power loss in the circuit, which means the loss on the cable or loss on the bus bars, which are used either as a riser or feeder circuits, okay. So and the loss on this kind of circuit certainly is determined by okay, just a second. Okay, so let's say you have a riser or whatever feeder circuit, okay. Okay, and the loss on the circuit, okay, is determined by the loss, determined by the current square and the resistance. And if it is a three-phase circuit, so it's multiplied by 3. Okay, and if you want to reduce the loss, that means that the current should be reduced. Okay, I should be reduced. Okay, so and in this case, okay, A, okay, option A, it is because the apparent power is reduced. So we know the apparent power, S is equal to, if it's a three-phase circuit, is equal to root mean square 3 voltage and I. And normally this voltage, okay, is 380 volt, okay, because the almost constant, okay. So if this one is reduced, okay, and the current is reduced. If the current is reduced, then the power loss is reduced, okay. So the loss in the circuit is reduced, okay, because the current in the circuit is reduced, or the apparent power is reduced, okay. So the answer here is A, okay, it's A. Okay, and number 8. Number 8, okay. A circuit supplying a motor with full load current 19 ampere is protected by a type C MCB. The starting current of the motor is 4 times of the full load current for 0.5 seconds. The ambient temperature is 40 degrees, and the circuit is installed with 3 other similar circuits. The type C MCB rating is proposed to be 20 ampere. Which of the following statement is correct? Okay. Well, the answer is A. Okay. So the A says the MCB type and the rating are correct. Okay. So we know for the purpose of sizing, okay, we need to follow the requirement. Okay, the design current should be less than the rating of the protective device. Okay, in this case is a fuse MCB, and it should be less than the current carrying capacity of the cable, right? So the design current here is 19 ampere, right? And the rating is 20 ampere. So it looks like it's fine, okay? The requirement is fulfilled, okay? Okay, but we don't know the cable size, so we don't need to worry about the requirement, okay, of this, okay, IN less than IZ, because we don't know the cable size, so we cannot make any judgment, okay? So actually, we are not required to do this, okay? So the first thing we can say that the MCB rating is correct, okay, because this is okay, right? And then we need to know whether the type is okay or not. So the type actually is determined by the mode starting current. Okay, so we know this mode starting current, right, is 4 times the full load current. So the starting current is equal to 4 times the full load current, right? Full load current is 19 amperes. So this is about the 76 amperes, right? Okay. So well, we have 20 ampere Type C MCB, right? So for this MCB, we know we have this kind of tripping curve, okay? Let's say, okay, this is Type C is from 5, okay, to 10, and this is the actual current over the current rating, and this is the T, operating time. So we want to ensure, okay, the starting current somewhere here. So this is the starting current. Okay. So if this requirement fulfilled, okay, the starting current is something like this, then we say the selection of MCB is adequate. Okay. All right. So we know the starting current is 76, and the multiple, okay, we divide this one by 20, right? 20 is IM. So this is like 3.9 something, okay? So less than 4. So somewhere here, this is like a 3.9, okay, 3.9. So it's less than 5, certainly, right? So there's no overlapping, okay, between the starting current curve and the MCB curve. So MCB, the Type C MCB will not cause any trouble to the starting of the motor. Okay, so then we say everything is fine, okay, with this MCB, right? 20 ampere Type C MCB, okay? And well, some of part, okay, says, okay, that some of students say that the MCB rating is too small because the effect due to the ambient temperature and the grouping is not included, okay? Both factors actually are used to determine the cable size, okay? So if you want to determine cable size, you have to consider this requirement, and then you need to consider CA, CG, and the CI, okay? But that part is actually not addressed, okay, in this question, so we don't need to worry about that, okay, because we have no idea about the cable size, okay? So we cannot make a judgment. So the answer is A, okay? So this is may cause some confusing, okay, when you do the question, do this question, okay? Okay, so it looks like some question, right? What do you mean it's correct? Yes, okay, okay. Type C is 5 to 10, okay. Okay, next question, number 9. Which of the following factors will affect the resistance of the conductor? The answer is all of them. Well, resistance determined by the conductor size, the bigger size, okay, of course, cause less resistance, right? And conductor length, of course, is determined by the length, right? In the impedance calculation, you have to consider length, okay? Ambient temperature, certainly the resistance is a function of the temperature, okay? Installation method, okay? Well, okay, this is not really clear, because the installation method, for example, let's say you have two cables installed together, okay? Installed together, okay? And then the compare with the case with a single cable. So that means that the other cable will generate a loss and eventually turns to the heat. And this heat will cause a temperature increase of the another conductor. And the temperature will be changed because temperature on the conductor is changed, then the resistance will be changed. So here we say the installation method also is a factor, okay, affecting the resistance, okay, because it will change the operating temperature of the conductor, okay, or the cable, okay, cable. Okay. So the answer is all of them, okay. Number 10, this is a straightforward question. Okay, if you read the notes, okay, you can find the kind of answer from the notes directly. Okay, given by the voltage drop, okay, provided by the COP for 4-core cables, PVC cables. Okay, which of the following is the cable impedance for 3-phase short circuit current calculation? Okay, if the cable length is 1 meter, okay, and of course we use the A, and root square means, you know, the impedance given in the table actually is called the line impedance, but in the fault current calculation we use the phase impedance, so that's why we need to divide the table value by root square 3, and again the resistance value because given the figure in the table actually is the resistance and the temperature 70 degrees. But in the fault condition, the temperature could be more than 100 degrees. So we need to consider this increase of resistance caused by the temperature change. So 1.15 is the factor, you know, caused by the change of temperature. Okay, and this factor again is given in the notes. So if you read the notes carefully, so you know where you can find this formula. Okay, in the notes. Okay. Okay. The question question 9 is 3 and 4 are correlated. 3 and 4. Yeah, correlated because the installation method actually is affects the temperature. Okay, so we cause change of temperature. Okay, okay, so it's affecting the resistance value. Okay. Number 11, which of the following is overcurrent? Okay, the answer is all of them. The current caused by the short circuit, so short circuit current is certainly is overcurrent. Okay, a current flow from a live conductor to the protective conductor. This is considered is like a short circuit earth fault current. Okay, and it's fault current again. A current exceeding the current carrying capacity of the conductor. So that means the current is greater than IZ. Okay. IZ. Okay. So this is the overcurrent. Okay. Also, it's a short overload current, but certainly it's a overcurrent. Okay. A current exceeding the rated current of the circuit again is considered overcurrent. Okay. Any current is greater than current rating, okay, of the protective device. Okay, so again, it's considered overcurrent. Okay, overcurrent. Okay, so the answer is A. 12. Which of the following is the current that occurs in the normal circuit condition? Certainly it's overload current. Other are the okay, not the normal current. Okay, earth fall current, earth leakage current, and the short circuit current. They are not considered in the normal circuit. Okay. 13. Which of the following will cause overload current? I think this is a relatively straightforward. The answer I already give you. Okay. Okay. The A, connect a portable heat to an already fully loaded circuit. So this is certainly this overload current. Okay, overload. Okay, and the other choices. Okay, basically are not considered okay overload current. Okay, for example, the lighting circuit protected by 10 ampere MCB supplies 4 numbers of 500 watts, 220 volts testing lamps. Okay, so I think if you know A, okay, so you don't need to worry about others. Okay, certainly A is the answer. Okay. 14. Which of the following is the requirement specific for the overload protection in a cable circuit? Breaking capacity. When breaking capacity, this is a basic requirement for the short circuit protection, so we do not need to worry about that. The current rating of the protective device is less than the cable current carrying capacity, so this is a part of the overload protection, right? So this is the one. Okay, so this is a requirement. Okay, overload protection requirement. And the protective device should be provided at the origin of the cable circuit. So this is not relevant, okay? Because the device for overload protection can be placed any point around the circuit. Can be at the origin of the circuit or at the end of the circuit, okay? Because overload current can be observed during the normal operation everywhere, okay, in the circuit. Okay, so the answer is A. Okay, 2 only. Okay. 15. Which of the following is the technology used for overload tripping of MCB? Okay, so basically we have 2 types mechanism or tripping technology. Okay, one is the thermal, one is the magnetic. And the hydraulic certainly is not relevant. Okay, so certainly overload protection is by thermal curve. Okay, so it's thermal mechanism. For example, we use the bimetal element. This bimetal element is certainly is a thermal technology. Okay, so the answer is A. 16. Which of the following is the instantaneous tripping current of a type D MCB? So this is a straightforward question. Okay, so C is the answer. Okay. Which of the following must be considered for short circuit protection? So those are the basic requirements, okay, for short circuit protection. Breaking capacity, certainly this is the one thing we need to consider. Design current of the circuit, this is not relevant, okay, because this is not for overload protection. Prospective short circuit current, okay, so this is also required. So the answer is 1 and 3 only, C. Okay. Let's see. Let's see any questions. For question 15, I have found that all types exist. 15. What do you mean all exist? Okay. For overload tripping, we cannot use a hydraulic. Okay. You never find a circuit breaker with hydraulic technology. Okay. All right. And the magnet is just for the short circuit protection, not for the overload protection. Okay. And the other question, 1.15, how can we get this one? I think I go back to the notes. Okay. The notes tell you how to find this 1.1, how this 1.15 obtained. Okay. 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 18. Circuit is protected by a fuse. Which forum is correct? Okay, among the about the relationships between IBIN and I2IZ. Okay. Well, basically you just to consider the requirement IB, IN, IZ, see which one meet can be obtained from this requirement, and then IT is less than 1.45 IZ. Okay, all right. So certainly, if you make a comparison, okay, you can see this one, okay, is right, and this one is 3 is right. Okay, so the answer is A. Okay. Yeah, this one, first one, you mean first one? The first one says I2 should be greater than 1.45. This is not right. Okay, okay. So yeah, better to read the question carefully. Yeah. Okay, 19. Which statement is true for a CT 1600 over 5 MP and 10P10 CTs? Okay, I think this is relatively straightforward. Okay, so the first term is the error, okay, or the accuracy of the CT. The second term is the multiple. The error is or the accuracy is obtained, okay, at the current equal to 10. This 10 is a multiple, 10 times the CT rating. So the answer is that the has an error less than 10% under the current of 16 kiloampere. Okay, so 16 here means it is 1,600 times the 10, so it is the 16 kiloampere. 20. Which one is possible breaking capacity of 32 ampere MCB? We have you can see a list of the current. Some of the currents not possible. Okay, so as I say in the lecture, MCB is a small size circuit breaker. The breaking capacity cannot be very bigger, and most cases is 6 kiloampere. Okay, of course some cases may be 10, but for the circuit breaker used in the residential building or in the residential or commercial building, okay, they have the breaking capacity of 6 kiloampere. So we call this M6 circuit breaker. Okay, M6 circuit breaker. So 15 kiloampere is not possible. 80 kiloampere is the one for a fuse. Okay, so D of course is not right. Okay, so the only thing, okay, we can consider is the B. Okay, B. Okay. All right. Okay. Those the MC questions. Okay. And anything about the answer for those MC questions? Okay. Okay, for other questions, other 9 short questions, actually the answer, the steps are provided. Okay, I think most of them, okay, the answer are not easy, not difficult to understand or not difficult to follow. Okay, so I don't think we need to go much detail about the steps. Okay, unless you have a question you want to ask. Okay, but there are a couple things I want to say it, okay, especially for the okay, let me see, okay, let's see. Oh, okay. As for the last question for this one, okay, the IDMT relay, and I think most of you, okay, did the kind of calculation, okay, and then find this TM, the value, because if you use this one here, and you will find that the TM will be less than certain value, greater than 1. But remember, TM, the time multiplier, okay, normally in the range 0.1 to 1.0, cannot be greater than 1. So if you put the number greater than 1, that certainly is not correct, okay? So the largest one is 1.0, 1.0, okay? Okay, so this is a you know, tricky point, okay, in this question, okay? The other things, okay, for this one, according to the latest version of EMS DCOP, the maximum resistance of the circuit breaker or circuit protected conductor from the main earthing terminal to the distribution board serving both socket RS circuit and the fixed equipment circuit, and which is the protected by a 40 ampere Type C MCB. So find out the maximum resistance. So we just use the requirement, okay, R times IA should be less than 50 volts, or R less than 50 volts, okay, and ZS over U0, okay. Either one is fine. So what I suggest to use the first one, which is easy, okay. So this one means, okay, actually I talk about this in the tutorial session. You have the main earthing terminal on the ground floor in the switch room. So you need to provide a circuit protective conductor to a distribution board. Let's say you have distribution board here. So, and this earthing terminal at the distribution board, and this resistance is called R, okay? And this R should be times IA should be less than 50 volts. And IA is the current which causes the protective device to operate at the 5 second, okay? So in this case, you have a type C, okay, 40 ampere MCB, and this IA is certainly can be considered is, as you can see here, 510. So 10 is actually in the worst case, okay, 40 ampere. So this is 400. Okay, so then you can find R is less than 500 over 50 volts, 50 over 400. So this one is equal to 0.1250. Okay, so this is the way to find out the answer, okay, for this question. Okay. Okay, and this is as for current three-phase Earth-4 current calculation. So I think this question is relatively straightforward. I don't know why some of students cannot get the answer. Okay, so you need to find the impedance for HV circuit and the impedance for transformer. Okay, this is for transformer. This is for HV circuit, and then use 220 volt here, and then you can find the for current 50.8 kiloamp. Okay, so this, I think this is relatively straightforward. Okay. Okay. Well, other question, I don't think any difficulty, okay, to because the answer, okay, already the steps are already provided, okay, so I don't think it's necessary to go all the detail, okay. Okay, so any question for the quiz? Okay, so far, any questions? Okay, well, if no questions, probably we stop here for the quiz, okay, and we'll talk about the final examination. Okay, so I guess the final examination is scheduled probably around middle of December. Okay, I can't remember exact the date. Okay, so basically the examinations are very similar to the questions in in the past years. Okay, so we have 4 questions. Okay, and you need to answer all those 4 questions. Okay, and the examinations is closed books, closed notes. Okay, so basically you are not allowed to use some reference material. Okay, in the examination. Okay, and the tables, the graphs we provide in the examination papers. Okay, and for the formulas, okay, I think for those difficult formulas we will provide it. Okay, because we don't have many formulas. Okay, or complicated formulas. Okay, used in the for this subject. Okay, but some formulas such as like the formulas for IDMT relay. Okay, such kind of formula will be provided. However, the formula for calculating the flow current of the motor will not be provided. Okay, so this one suppose you know, okay, very well. Okay, so let's say that kind of formula you suppose you know. Okay, let's say flow current equal to the output power of the motor divided by efficiency, load square 3 line voltage and the power factor. Okay, so such formula, okay, will not be provided. Okay, suppose you know very well. Okay, but the formula for IDMT release, okay, will be provided. Okay, and again the formula for voltage drop calculation will not be provided. But for the voltage drop calculation, I suggest that you need to use the simplified formula only. Okay, I do not need to consider the complicated formula by considering like the temperature factors or power factors. Okay, in the formula. Okay, just use the simple formula. Okay, so again the formula is very straightforward. Okay, so will not be provided. This kind of formula certainly will not be provided. Okay, and there are some other formulas I couldn't see any difficult formulas. Okay, okay. So that's a close notes examination. Okay, and of course everything all talk about in the lecture will be covered. Okay. So certainly I suggest you to work on those questions in the past few years. Okay, I mean the past few year examination papers. Okay, and well, if you have some questions, okay, you can come to my office or may send an email to me. Okay, because you certainly you have sufficient time for review. Okay, before the examination. Okay. All right. So anything else you want to know from me regarding the examination? Yes. Oh, okay. I don't see any big open-end questions. Okay, maybe a little bit about some concept. Okay, uh, like so, what is over breaking capacity? What is or something like that. Okay, but not really big one. Okay, you do not need to write a long paragraph. Okay, for such short definition questions. Okay, just a short paragraph. Okay, a few sentences. Okay, will be fine. Okay, so I don't expect you to write a large stuff. Okay, for such some very short. Okay, I mean simple definition type of questions. Okay, so majority. I mean the major part is the calculation. Okay. All right. Any other questions? Okay. Well, I guess you still have some time. Okay, at least a few weeks to prepare for the final examination. Okay. I guess probably you will have some questions. Okay, when something maybe sometime just around the before the examination. Okay. So in that case, okay, you can talk to me. Okay. Either uh, by email. Okay, or telephone or the or just come to my office. Okay. All right. Okay. If you don't have okay, it seems to me there's some questions. If you don't have big questions, then we stop the discussion. Okay, lecture today. Okay. All right. You still have a question about the 1.15. Okay. So I guess you just open. Let me open the notes. Cable sizing. Oh, not cable sizing. Okay. For current calculation. So this is 1.15. So this one tell you how to get this 1.15. Right? Is that correct? Is it clear? So you consider the temperature, initial temperature of the cable, which is 70 degree, and the final temperature is 160 degree, and then take the average value. Okay. And then use this formula here. This is a temperature factor. This is a 115, and this is the ambient temperature, which is 70 degree. And then when you find that the factor here is 1.15. Okay. All right. And for XLP cable, this is a 1.25. All right. Is that clear? Why 25 mm squared is used? Okay. So this already tell you why 25. Okay. I think based on this is the minimum current carrying capacity, 113 amperes, and then the cables here. Let's see, the multi-core PVC cable. Okay, multi-core PVC cable, ARMA cable. Okay, so okay, so you have to use the data sheet. Okay, let me find a data sheet. Okay. Okay. Anyway. Okay. I think you try to use the data sheet, because if I move that one there, I have to close this one and then again. Okay, so I think you I checked table 35 for A4 A64. Okay, let me see. Okay, so let me 115. 13. Multi-core. Okay, PVC. This multi-core non-armored. Okay, multi-core armored. Okay, so single core. This is single core. Multi-core armored PVC. Okay, so it's not easy. Okay, let me see. Okay. Okay, I guess if you are using three-phase circuit cable, okay, because this is a 220 volts. This is a single phase. So if you use a single phase, so the cable size, okay, so this is single phase, a two-core cable, single phase. So if it's a single phase 25, yeah, so the current rating table value is 125. So single phase. Okay, the table value is 125, 28. Okay, so that is good enough. Okay, this one is, and the IT here is 113. So this size is 25 square. Okay, so if I think you are using consider this a three-phase circuit. So if three-phase circuit, and then you have need to use 35 mm square cable. Okay, so I think that's the reason why you choose 35. Okay. All right. Okay. Good. Anything else? Okay. If you don't have any question today, so I just stop here. Okay. And again, you can talk to me later. Okay. Voltage drop. Okay. I said a simple approach. So the voltage drop is just equal to let's say we call it VD. Okay. Z table value. Okay, times the design current and the length, and divided by 220 volts or 380 volts. Okay, times 100%. Okay, use this approach. Okay, I use the formula like this. Okay. Okay, so we call this the simple formula. Okay, okay. All right. Okay, so we finished. Okay. Okay. See you later. Okay. Exam is difficult. Okay, just go back to check the past year examination paper. Okay, I cannot tell you whether easy or difficult. Okay,